Okay, this next tutorial, we're going to use the heat equation for a non-chemical process. So this won't be necessarily equivalent to enthalpy. So enthalpy is, we're going to save that topic for when we use heat equation for a chemical reaction or a dissolving process. So this, and when I say non-chemical process, that means just, all it means is something's heating up or something's cooling down. So, a quick background on this is getting the correct sign for Q. So before we dive into this problem, let's go over a couple terms for Q. So Q is heat, okay, and it's measured in joules. Mass is M is mass and it's measured in grams. C is going to be joules per gram times Celsius, and then delta T is going to be in Celsius. And if you multiply all these together, notice you get joules. The grams cancel, and then the Celsius cancels, and then you'll get joules for Q. So a couple things about Q, because it's important to get the correct sign for Q. When Q, so Q is negative when the substance loses, and I'm going to put quote unquote loses heat heat energy, because as we know from the first law, heat is never lost or destroyed. It just changes direction from system to surroundings or surroundings to system. So when the substance loses heat, Q is going to be negative. Now, some other synonyms for lose means the sub or that we could see in a word problem are the heat energy decreases, so watch out for that term. Or heat is uh, those are actually like the main two terms. Okay, and we'll see Q is positive when heat is absorbed, um, or when heat is, another term you might see is when heat is gained. Or oh, I forgot another term for negative. The other main one was released, when heat is released. Okay, so gained, absorbed is positive. Um, or taken in. That's the other word I was thinking of. So or heat is taken in, then Q is going to be positive. Okay, so on this problem then we have, what is the mass? So we're solving for M. That's what we're solving for, of an aluminum object that requires 89,000 joules of energy to increase from 25 to 75 Celsius. So I need to actually look up something, and I need the specific heat of aluminum, which is 0.89 for this problem. So C for aluminum is 0.89 joules per gram times Celsius. Okay, so we're solving for M, and M is going to be equal to Q divided by C delta T. Q in this problem, it says the object requires 89,000. So our Q is going to end up being positive. So it's a positive 89,000 joules divided by 0.89 joules per gram per Celsius times delta T. So the energy, it increases from 25 to 75. So TF is 75 and TI is 25. Okay, so now if I do this problem, I'll end up with, Okay, then I get this. So I get the mass must be 3,560. And because of my sig figs, you should get 3,600 uh, grams. Okay, notice all my units cancel here. So this is degrees Celsius, and it cancels. Okay, and joules cancel. So you get 1 over grams, or grams, for your answer. Okay, you guys try this problem, this one. Okay, make sure you keep track of your signs, and that means pay attention to this word, heat is released. Okay, so you have to know when you're given heat whether to make it positive or negative. Okay,